This is Worksheet 5.7, Exercise 8. Pause the video and read through the question. We are given the rate at which water enters and leaves the tank as separate functions, W of t and R of t. We will have to combine these two to find the function for the net rate of change. First, let's consider the rate at which water enters the tank. W of 15 equals 132 gallons per hour. The rate at which water leaves at the same moment is R of 15 equals 253 gallons per hour. The net rate of change would be the difference of these two, W of 15 minus R of 15, which is negative 121 gallons per hour. So at time t equals 15, the amount of water in the tank is decreasing at 121 gallons per hour. The total rate of change is negative, so we know that the amount of water in the tank is decreasing at t equals 15. This is the answer to part A. Part B, we are told to find how many gallons of water are in the tank at time t equals 18. We just found in part A that the formula for the net rate of change is W of t minus R of t. Integrating this would give us the change in the total amount of water from time 1 to time 2. So we first write this expression from t equals 0 to t equals 18. And we must not forget that we already had 1200 gallons at t equals 0. Adding the amount of water at t equals 0 to the amount that got added from then to t equals 18 would give us the total amount of water at t equals 18. Using your calculator, solve for this expression, and you should get 1310 gallons by rounding to the nearest whole number. This is the answer to part B. In part C, we are told to solve for the time when there's an absolute minimum amount of water during a closed interval of t. We must begin by finding the critical points, or when the rate of change is 0. We know that W of t minus R of t is our function for the net rate of change. We set this equal to 0 and solve for t. This would be the times when there's a critical point. Solve for t using the nsolve feature on your calculator. In case you don't know what this is, I'll go over it briefly. Inside your calculator, click Scratchpad, Menu, Algebra, and then Solve. Type in the expression, and then a comma, and the variable you want it to solve for in that expression. For this problem, it should look like this. Press Enter, then you should see many t-values that satisfy this equation. Choose only the t-values that are between 0 and 18, because that's our given interval. This leaves us with 3 t-values. T equals 0, 6.495, and 12.975. Now we must determine which one of these has an absolute minimum. At t equals 0, we're given that there's 1200 gallons of water. To solve for the amount of water at t equals 6.495, we use the method from part B. 1200 plus the integral of W minus R from t equals 0 to t equals 6.495, which results in 525 gallons of water. Doing the same for t equals 12.975, we get 1697 gallons. At t equals 18, we have already solved for it in part B, which is 1310 gallons. From this, we can conclude that there's an absolute minimum amount of water at t equals 6.495. This is the answer to part C. In part D, we are told to write but do not solve an equation involving an integral expression that can be used to find the value of k. Since at this point there's no water being added, we can ignore w of t. The integral of r of t gives the total amount of water that is taken out of the tank from time 1 to time 2. The lower limit will be 18 because that's when water will start to be removed, and the upper limit is k because that's when all water has been removed, or in other words, when water stops being removed. By the time t reaches k, all 1310 gallons of water that were present at time t equals 18 should be removed. And therefore this equation is the answer to part D.